So today is the first lesson before we begin chapter 2, which is, for us this year, we've moved chapter 2 to the end of the course, so I think you'll find some of what we do today after tackling quadratic functions. I think you'll find this fairly straightforward, but this is a new unit, and so with every new unit, we want to make sure that you have the prerequisite skills, the readiness to begin. So that's what we're going to do today. So let's start with a very simple concept from grade 9, which is slope. So you should have seen a lot of slope last year, and most of you will remember, well, what is slope? If I were to ask you what slope is, my guess is that the majority of you would respond, well, slope is equal to rise over run. Right? Well, what does that really mean? That means that we're talking about how quickly our line is either ascending or descending, right? That's what slope describes. It's the rate of change of that graph. And so in this case, I can look at the slope as, I can look at the rise as being, well, if I'm describing how to get from my first point here to point 2, I can talk about the rise and I can talk about the run. So here, I would have my rise, and here would be my run. Now, we know this, right? Now, another way to think about this, we can think about it as describing the change in our y values relative to the change in our x values, right? Because I know there's I had to go up by a certain amount in the x direction, and I had to change by a certain amount, that was in the y direction, and a certain amount in the x direction in order to go from point 1 to point 2 here. And so, often people will count squares. There's no scale on here, so we want to be careful about that. Count squares to get their rise and their run. And certainly that is a simple way to calculate slope if the numbers are really friendly. The reality is that we use slope in all sorts of contexts where the numbers, the data points that we have, are not necessarily provided to us on a graph, and they may not be really nice numbers to work with. So for that reason, an alternate way to think about slope is to think about our rise as our change in, and that triangle means change in, y, as it relates to our change in x, right? And so change in, we say that change in, sometimes it's also, we use the term delta to describe that. So you may see me call it delta y or delta x, right? So we can write that out. So change in y over change in x. Now, again, our change in y we can get by looking at, well, how much does y change? It changes if we know the value of y2 and we know the value of y1. And the same goes for x2 and x1. So by subtracting y1 from y2, and the same with x, we get a formula that looks like this. So y2 minus y1 over x2 minus x1. And of course, this is not an introductory video. This is stuff you should have learned from previous years. So I'm hoping this seems familiar to you. Let's take a look at an example so that we practice this skill before we move forward. And so here's an example where, they're simply giving me my x and my y coordinates for 2 different points, and they're asking me to calculate the slope. So I want to know the slope, and they're giving me 2 coordinates, this guy and this guy. So there are no squares to count, and so how would I find out rise and run? Well, it's easier if I use the formula. So you may remember from grade 9 that often when we talk about slope, we use the letter m to represent slope. And so I'm going to write it out that way. We know that slope is equal to our change in y, so y2 minus y1, divided by x2 minus x1. And so often at this stage, students will say, well, which point has to be x1, y1, and which point has to be x2, y2? I would ask you to try both out and to see what results you get. I think you'll find that regardless of which point you call your first point or your second point, it really shouldn't make a difference at the end of the day, and you should end up with the same answer. So I'm going to call this first point just arbitrarily x1. This will be my x1, y1. And then this guy over here, that'll be my x2, y2. And so now it's just a matter of taking the associated values and substituting them into my formula. So m is equal to the value of y2, which I can see is 7, minus the value of y1, which is 5, divided by the value of x2, which is 7, which is negative 1 rather, minus the value of x1, which is 2. And then so simplifying this, I end up with my slope, so 2 over negative 3, which is negative 2/3. And there I go. That's it. So there is one caveat, and things that I see quite often is students will use a particular y1 and a y2 and put them in a particular order as they substitute it in, but then sometimes for whatever reason they will decide to flip the x's in different positions, and that won't yield the same answer. So just make sure that, it doesn't matter which point you're calling the first and which you're calling the second, but once you make that decision, those coordinates are firm, and you have to kind of stick to that in order for your formula to work. All right, let's move on. So let's look at, knowing about the equation of a line is really important for analytic geometry. Remember that ordinarily this would be the second unit in our course, and so it relates very much to our first unit, which was about linear systems. So we're going to, think along those lines, imagining that we had no prior knowledge of quadratics or anything of the sort. So let's just revisit what you hopefully remember from last year. This guy right here, y equals mx plus b, it would be the one equation that you would remember, I think, most importantly. There we can see our m, which is our slope, and there we see what b is. Do you remember what b is? It's our y-intercept, right? And so having knowledge of slope and y-intercept will help us formulate the equation of a line in what we call the slope-intercept form. Right? Not a big surprise there. Now, what you should have seen as well, potentially, is what we call this equation of a line in standard form. Now, some of you may be saying, well, this guy right here looks a lot like a quadratic. But remember, in order for a quadratic function to be quadratic, there needs to be an exponent of 2 on our independent variable. And in this case, we don't see that. So this is definitely linear because the exponent on our x variable is understood to be 1. So all we do to go from slope-intercept form to standard form is we just rearrange the equation. That's it. We just rearrange an equation with a couple of other caveats. And here are those caveats. The value of a has to be positive, a positive value, which means if a ends up being negative when we rearrange the equation, we simply have to multiply our whole equation by -1 in order to change the signs of all of the components. Another thing that we need to mention is that the values of a, b, and c, those coefficients, cannot be fractions. So in other words, if they are fractions, we need to multiply by some sort of value to eliminate the fractions. Often that's some sort of common denominator, and we've seen that before. So those are the two caveats in order to get an equation in what we refer to as standard form. Now, last but not least, is what we refer to as point slope form, which you may or may not have gone over in your grade 9 course. Not so sure. But so let's dissect some of this. So in this equation, our m is of course the slope as we would expect. But what's new here is this y1 and x1. And all that represents is a particular point on the line. So hence the name point slope form, because you're going to use the coordinate, one coordinate, which is an x1, y1 coordinate, along with the value of the slope in order to come up with the equation. If I'm being honest, I prefer the first two, and I'll use the point slope form when need be if I'm asked in a question, but it's, for me, it's unless I'm asked, I typically tend to not utilize it as a way of going about things. All right, let's take a look at some examples. So in this example, it says find the equation of a line, but it specifies that it wants the equation of the line in standard form. So remember the caveats there were that the value of a, I'm just going to write it out by the way. So, equations in standard form would look like this. I would have ax plus by plus c equals 0. Right? So I've moved all of my terms to one side of the equation and equating the other side to 0. So if I'm asked specifically for my equation in standard form, I need to make sure I'm doing that part of the question. But that may not be where I start. So let's take a look at this question. It says, in this question, my slope has a value of 1/2, and my y-intercept has a value of -5. So I like to consolidate that. So I know that I'm just writing out my givens here. My slope is 1/2, and my y-intercept, which has a symbol b, is equal to -5. So given that I have information about the slope and the y-intercept, I'm going to choose to start with the equation of a line in slope-intercept form, which is, the most common form, y equals mx plus b. And I'm going to substitute in what I know to come up with a linear equation. And even though it's not in standard form, it's in a form that I can work with and potentially get to standard form. So substituting in my slope of 1/2 and my intercept of -5, I get y equals 1/2 x minus 5. Okay. Now, so let's work to get it into standard form. So to get it into standard form, I notice that I have a fraction here that I don't really like. And in our getting ready skills for the course, we looked at one strategy for getting rid of fractions, which was to multiply the whole equation by some sort of common denominator. Now, since I have only one particular fraction, I'm going to multiply everything by that denominator by 2. All right, and so distributing that 2 to every term in that particular equation, I get 2y equals, 2 times 1/2 is 1, right? So 2 times 1/2, right? That's always, if I multiply by that, then my numerator and denominator, or my 2 and my 2 will cancel out. So I end up with 1x, or simply x. And then minus 10 when I multiply the 2 by the -5. So now remember, I want to get it into standard form. Standard form means getting everything, all of my terms to one side with the other side equal to 0. So I also need to make sure that the coefficient of a is positive. So I'm noticing right off the bat that my coefficient of my x term, a, is a 1, and it's already positive on this side of the equation, which to me means that the thing that makes the most sense, that is the most efficient, is to take this 2y and then just move it to the other side. So that's what I'm going to do. So 0 is equal to x minus 2y minus 10. I'm going to include my terms with variables first and in alphabetical order, as is the convention. And there you have it. I have done it. All right, so let's look at a second example. This says I'm looking for an equation of a line, again in standard form, that has a slope of 3 that passes through the point 1 and 4. And so I need to remember that anytime they give me a point, that represents an xy coordinate, which can help me find some other unknowns. So far I have that my slope is equal to 3, and I have an xy coordinate that is 1 and 4. And so I could use my point slope form and start with that. I'm going to actually not do that. I'm going to give you another option. Maybe let's look at both of those. So if I were to use the point slope form, I'm just going to do this real quick. I have y minus y1 equals m times x minus x1. And then I would simply substitute information that I know. So this would be my x1, y1. So I would have y minus whatever y1 was, and that's 4. There's our 4. I have my slope, which they give me is 3, and then x minus whatever x1 was, which is this. And then I could go from there, rearrange it into standard form by just distributing and moving everything to one side. That is one alternative, and that would eventually lead me to standard form. I'm going to show you what seems for me to make more sense or seems to click more with my brain. Either way, you're good. I am going to choose to again go with y equals mx plus b. And so right now what I do know is I know my slope. So I'm going to substitute in the value that I'm given for slope, which is that m equals 3. And I'm going to substitute that in. So y equals 3x plus b. And so my unknown right now is well, what is b? So all I'm going to do is I'm going to take this, I'm going to take this coordinate here and just substitute that in for my x and y in the second step here. So I'm going to say, well, y was 4 when x was 1. And then that just lets me solve for the single unknown that I have here, which is my y-intercept. So 4 equals 3 plus b. So moving my 3 to the other side of the equation, I get that b is equal to 1. And so now I can go ahead and start with my equation in the form y equals mx plus b. So that way, you have fewer equations to work with. So, I would go back to my original, which was y equals 3x plus 1. And now all I need to do to get into standard form is to simply move my y to the other side. So 3x minus y plus 1. I'm just going to double check things, make sure the coefficient of my x is positive. Check, it is. I'm going to make sure also that I have no fractions anywhere. I don't. So in fact, there I've gone about it. So hopefully that makes sense. Couple of different strategies, no judgment. Whichever one you want to use will work fine. One last example for today. Remember again, the question was determine the equation of a line in standard form. But in this case, the information that they're giving me is they're giving me coordinates. They're giving me two points here. And so I'm going to work with that, right? So let me write out what the information that I have. I'm going to choose one of them to be my point, my x1, y1, and I'm going to choose the other one to be my x2, y2, right? And then plug that into my slope form. So now this is my strategy. This is the strategy I'm using. Number one, I'm going to first calculate slope. So determine my slope. That's going to be my first strategy. Then I'm going to figure out the rest of the equation by figuring out what b is, using the same steps as I used the previous example. And I'm going to do that by choosing one of the 2 points here. And then I'm going to assemble it and just get it into standard form. Those are the two things. Those are the two strategies, and then the third is just to get it into standard form. So I would like for you to try that and to pause the video and come back when you've applied my strategy, just to see that you're on the right track. Okay, so figuring out my slope. So slope is going to be 8 minus 6 divided by -3 minus, and we want to be careful here, minus -2. My guess is some of you may have made a mistake there. So that will give me 2 over, so -3 plus 2 gives me -1, so my slope ends up being -2. All right, next I'm going to figure, so we'll call that step 1. Okay, step 2 involved figuring out b. I'm going to use the second method that I used, using the slope-intercept form to solve for b. So it doesn't really matter which of the 2 points that you're given you choose. I'm simply going to choose the first one because if these are both points on this line, either of them should work with any equation that we use, right? So I'm going to go 6 equals -2 times whatever x is -2 in this case, plus b. So 6 is equal to 4 plus b. Moving my 4 over and subtracting, I get that b is equal to 2. So that's going to allow me to put these pieces together to get something that's in standard form. Let me do that right here. So, so far this is where I am. So I would have y is equal to -2x plus 2, subbing in our slope and our intercept that we found. And so now all I need to do to get this into standard form is to move everything so that I have, well, I already have no fractions, so I'm good there. And so I'm going to choose to move this -2 to the left-hand side because it's negative on the right-hand side. And so that will give me 0 is equal to 2x plus y minus 2, because remember I'm also going to have to move my 2 over to the other side. And so there I go. There's my equation in standard form. So I'm going to give you some algebra with pizzazz worksheets to try out, as well as some slope calculations. If you need to do the slope calculations to master that, then you go ahead and do that. Otherwise, feel free to do as much of these prereq skills as you need to feel competent, because I'm just going to be moving right into the content as though you have this in your back pocket, that you understand it well. So as always, make sure you reach out if you have any questions.